So in this discussion we are going to talk about division of two polynomials under a finite field. So if you say finite field, it will have n number of elements. So we are going to take two polynomials and we can name it as f of x and g of x. So the elements of these polynomials are taken, the coefficients of these polynomials are taken from the field notice associated with the problem. So in this problem we have f of x equal to 3x square plus 4x plus 2, g of x equal to 6x power 4 plus 4x cube plus 5x square plus 3x plus 1, and we say these are polynomials in the field finite field because they have only 7 elements. So z7 of x, so x is the variable here. So here I am dividing f of x with g of x. So I take g of x and I divide by the divisor 3x square plus 4x plus 2, and I am trying to understand what the quotient, what is the quotient I will get and what is the remainder I am going to get. So this is my plan, and I will find out whether it is coming, whether the results are in, that is whether the results are in the field z7. So here in the first case I understand that since it has only 7 elements, the elements can be from 0 to 6. So the coefficient of each and every variable here should align with the field values. Okay, so first I take the first term 6x power 4 and I divide with 3x square. So the result I get is 2x square. So that will be taken as the quotient. With that I am going to multiply the divisor and I will list out the elements to work out the problem. So that is how I have proceeded. So you can see I have very clearly explained how I work here. So when you multiply the terms, suppose if you get any element bigger than the given element, that is bigger than the element in the set. For example, if you are multiplying 4 into 2, you get 8. That 8 is not available in the field. What you do? You subtract with the n value. Here n in the field is 7. 7 is the number of elements. So 7. So 8 minus 7 is equal to 1. So in the place of 8, you can equivalently write 1. So likewise, whenever the element goes beyond the element of the field, you can work on that by subtracting with the n value. So the process of division happens, polynomial division happens like this. Then you can cancel the like terms and we can go for the next step. Similarly, you can take an element in the quotient in order to work out the second level of values. So in the second level of values, I am trying to understand the quotient and I am trying to substitute in the quotient part.